Okay, good morning. Bell ringer today. There's a jar of beans in the classroom. I've instructed whoever's here to make sure that it is on the front table in front of my desk. Pass that around. I want you to take a look at it. And I need to see if you can guess the total number of beans that are in this container. Okay, so pass that around. Take your time. Take a guess. Please take your time on it. I don't care how you determine, but come up with an idea how many beans you think are inside this container, and then write it down, and we'll discuss that in class, okay? So I'm going to go ahead and move on. I'm assuming you've written it down. Okay, so let's talk about good things. Share some joy. Last week, I shared with you that my children had gotten their beehive stolen that they had worked 2 years to get. Well, on Friday, KAGS came over and interviewed my children about their loss and how they lost their bees and what they thought about it. And it was a pretty good interview. Not only that, the Eagle contacted my wife and talked to her about it. And there's a really good story in the Eagle about my children losing their bees. Well, in the process of that, and in the process of actually listing the fact that we lost our bees in social media, which is exactly how the news reporters found out about it. The community of beekeepers, not just in the local Brazos Valley area, but in the nation, they wrapped their arms around us and they said, we really want to help. And it just so happened someone local donated 2 full hives of bees. And so we went and got them Saturday, and we replaced the bees. And actually, these beehives are ready to harvest the honey right now. And so next Saturday, we're going to inspect them and possibly pull some frames out and actually harvest some of that honey. So that's really good. Not to mention that there's a lot of other people that want to give us more hives. Even though we already got hives, they said, we told them we don't want to be greedy. And they're like, it doesn't matter. Your children put 2 years of work into it, and somebody took that from them. We want to bless them tenfold. I think you can suffice to say that sometimes when you're beset with trials and you lose something or something is taken from you, the blessings are returned tenfold. I think that's written somewhere in some great historical document. You might find it one day and take credence to it. Anyway, that's my good things. Once again, I want to invite you to share your good things with me. I would love to share someone else's good things in one of these broadcasts or one of these videos so that the other people watching this video can hear the good things that you guys have going on in your life. All right, so let's move on. So when you guess the number of bees in that, or beans, I'm sorry, I was talking bees, so I started talking beans. When you guess the number of beans in that jar, what strategy did you use? Did you use a strategy, or did you just flat out guess? And if you did use a strategy, what strategy did you use? Think about it. Did you randomly guess, like I said? Did you use a really good strategy for your guess? Like what strategy you used for your guess? Think about it. Did you measure the number of beans that go across one way and then across the other way and then up and then do some volume multiplication? Maybe that's one way to do it. How is guessing the number of beans in a jar similar to estimating a large crowd at an event? Well, I don't know. I want you to ponder that for a minute. You got a large crowd at an event. How would you estimate that crowd? Is there a way you could do it? And if there is a way, what is that way? And how does it prove that you've estimated or come close to thinking what that crowd size is? So if you look on the floor, there is a 5 foot by 5 foot square taped off for you to use. Okay. Now I want you to use that device, but it's going to take some audience participation. And I know I have enough kids in every class to do this. So if you're watching this right now, I want you to invite your peers that are right next to you to come back to the square and get as many people in your class into that measured device. I'm going to have the substitute, if I'm not here, help you do this. If I'm here, I'll help you do it. But it needs to be done in order for you to finish this assignment. It actually is going to be it's implemental to you understanding this particular facet of the instruction right now. So you get people in there, you're going to try to get and squeeze as many people in there, and your feet must be inside the tape. And you count the number of people in there, and then I want you to think about what you've done. Once you've got that number down, remember it, because you're going to get that number that you should be able to comfortably fit inside. Don't squeeze so much that you think about, okay, you're at a standing room only concert. How close are you going to stand to people? Probably not that close, especially if they got a beer or something. No offense, but that's what happens at concerts. They got a drink of some sort. It's going to spill on you if you're too close. So stand comfortably. That's what you're looking for. All right. Make some calculations from this information. How do you do it? What is the ratio to the number of students to the area of the rectangle? First of all, if it's a 5 foot by 5 foot square, what is the area of that rectangle? 5 by 5 is 5 times 5 or 25 square feet. So let's say, for instance, you have 12 people in there. So you have 12 people for 25 square feet. All right. Well, how does that help us? We can make some inferences. Can the ratio help us? I think it can. Consider this. We determine our ratio how? Okay, so if we take a calculator, we have 12 people every 25 square feet. Well, how many people do we have every square foot? 12 divided by 25 is 0.48. So we have a half a person every square foot. Or you can even consider this, 1 person every 2 square feet. That would be a fair assumption. Of course, you can't have a half a person, can you? Okay, do we use it as a fraction? We did say half a person every square foot. Or was it a decimal? We could have put 0.48 people per square foot, which was the actual division. When you divide 12 by 25, you get 0.48. Or you could make it separated by a colon. So for instance, when I said there's 1 person every 2 square feet, that's a ratio of 1 to 2, or 1:2. So there's 3 different ways to look at this particular ratio, and you need to understand all 3 ways, because those all can be questioned of you in this particular unit. All right, let's use this ratio to estimate stuff. Can you estimate the size of a crowd 10 feet deep on both sides of the street standing along a 1-mile section of a parade route? All right, let's qualify this. We know that there is 1 person every 2 square feet, right? Well, if the size of the crowd is 10 feet deep on both sides of the street, that's a 20-foot wide crowd area. You see, 2 10-foot wide sides of the street is a total of 10 plus 10 or 20 feet. But what about the 1 mile? So first of all, you have to know that 1 mile is 5,280 feet. If you multiply 20 times 5,280 feet, we have 105,600 square feet. Well, remember, we said that you have 1 person every 2 square feet. Well, if there's 105,600 square feet and there's 1 person every 2, to find out how many people, we just divide the square feet by, that's right, you only divide it by 2. So 105,600 square feet divided by 2, we should have enough area for 52,800 people. But wait, are we even close? What are some of the problems with this sort of estimation? So first of all, how many different square foot areas that are 25 square foot fit in that big area? Well, we'd have to divide 25 into 105,600 square feet. So 105,600, we're going to divide that by 25. There's 4,224 of those 25-foot squares. And then we fit, we said 12 people, right? We're going to multiply that by 12. That's another way to find out how many we got. And it says 5,688 or 50,688. Well, that's a 2,112 person difference. So what's wrong with that? Well, there's nothing wrong with that if you realize that what we're talking about is estimation. We're only estimating. Estimation is what we call something we do when we don't have clear enough information to make a precise answer, okay? Estimation is just that. It's a round figure that is close to what we believe it is. There's a way to do it, and we'll talk about that in a future lesson, probably tomorrow, about how we find a low and high end to this estimation to help better configure what our estimation is. All right, so we don't need to estimate those examples. Why? Because concert venues don't need to estimate crowds in open venues, do they? Why? What do? They sell tickets, right? They sell tickets. They know exactly how many people are going to be there, correct? And if they're smart, even though people buy tickets, doesn't mean they're going to go. So they're going to count people as they walk in, right? So what are some examples where this form of estimation is useful? Let's think about that. What are some examples where this form of estimation is useful? All right. Let's say we do have a parade for President Trump coming through town in a motorcade. And whether you like him or not, it's kind of like a train wreck. No one can take their eyes off of him. They don't care what happens. They want to see. And so everybody and their brother, mother, sister, cousin is going to be there to watch him drive by. Well, the Secret Service makes it their job to keep dignitaries and our president safe. So they're going to have to estimate what is the risk factor. And one of the way they'll determine the risk factor is to estimate the crowd size. They can limit the risk factor by reducing the number in the crowd size. But if they estimate the crowd size just on a particular aspect of their route, they can determine how many people could possibly be in that particular area. So that would be useful to them so they can reduce the size or reduce the area that people can congregate, and that would reduce the risk. A different way to look at the same problem. Let's think of this. Experts estimate the most folks occupy 2.5 square feet. So we can use this information to estimate the size of the crowd from the first question. Okay, so we had estimated a ratio of 1 person per 2 square feet. We already did something like this. And we went back and we looked at it as 12 people per 25 square feet. Well, if we have 1 person every 2.5 square feet, we just take the total amount of square feet we said was 105,600 feet. We're going to divide that by the number of people in 2.5 square feet. We're going to divide it by the square feet that 1 person occupies. And then we can find out how many people fit in that particular area. If 1 person fits into 2.5 square feet, if we divide 2.5 into the total area, 105,600, we determine the number of people. And that is 42,240 people. So it's a little bit less, but in my example, it didn't matter. Now, if you actually did participate and find out how many people fit in that square, your number might be different than 12. You might get 13. You might only get 10. And if that's the case, you need to double check and see what's your ratio. If it's 10 per 25 square feet, you're going to find that there's fewer people that fit in there. If it's 14, more people fit in there, and you'll have more people in the larger area. All right. Experimentation is actually a way to look at a similar problem. We're going to do that. Someone stood and watched the parade, counting the number of folks that passed by a parade in a minute. Could they estimate the number of people participating if they knew the total time the parade took? So in other words, someone's standing there and he's watching the people in the parade walk by. And in 1 minute, they counted 27 people. And the parade took an hour and a half. Well, if 27 people went by in a minute, well, how many minutes are in an hour and a half? That's 90 minutes. 90 times the number of people that walk by in a minute, that's 27. So the number of participants is 90 times 27, or 2,430 people participated in the parade. So, I mean, it's another way to look at the problem. We're not looking at the crowd. We're actually looking at the people that participate. But you get the idea. We're estimating. We have no idea how many people are actually in the parade, but we did a little estimation by counting the number of people who went by in a minute and then measured the amount of time it took for the entire parade to proceed. So, ponder the use of estimation. What other methods could be used to estimate the size of a large crowd? So, one way Some people do it in open air coliseums. For instance, the Roman Colosseum doesn't have seating chart. Obviously, it's stone seating. Back then, the way that the emperor would determine, he'd have a guy count. He'd have a big square painted in there, and he would count the number of people in that square, just like we did. And he knew how many squares were in the Colosseum. And he would count the number of people in there and just multiply by the number of squares in the Colosseum. And he could estimate the crowd. Now, this didn't always work. That only worked if he had a full capacity crowd. If he had a full capacity crowd, generally speaking, he had the same amount every time with very few differences. But that's the way they did it. How and why the crowd size estimates supplied by an event organizer might differ from estimates made by other groups. Well, now this goes to a little bit conjecture here. An event organizer might want to overestimate his crowd to entice more people to come, or to entice artists to come, because the more people that come, the more money they make. And they might entice the people that own the venue to let them have that concert, because it would make that venue some more money too. So they might want to overestimate. On the other end, the event venue might want to underestimate the crowd, because we all know that the fire marshal has rules that he must abide by. Can only have a certain capacity in there, because otherwise it becomes a danger or a risk if there's a fire hazard, because people will injure each other trying to get away from a fire. And so the larger the crowd, the more risk there is to injuring people in the event of an emergency. So I'm going to leave you with this. A truly great friend of mine for many years left for heaven. A few years back, he left a great phrase that I like to share. I share it everywhere. Scott died of lung cancer not too long ago, 2015. To y'all, that may seem like a long time ago. To me, it's not long at all. Went to high school with him and his brother. Truly dear friend, good missionary to Africa. I stayed close friends to him till the very end. It was really sad. But he did share this, and everybody that knew him and that loved him still share this today. This is Scott. Really good guy, very open-hearted person. Give you the shirt off his back. He would even give you the beard off his chin if he thought it'd make you look better. That's the kind of guy he was. But he coined this phrase, be blessed, be a blessing. I sign off a lot of my videos with this phrase. He's a wonderful guy. Anyway, there is an assignment in the Google Classroom. I expect you to go look at it, take a look at it, and do the assignment. It is for a grade. Have a great day. So have a ball, y'all.